Alright, last problem here when we're talking about solving a quadratic equation. We're currently in the process of solving these equations using slip and slide method. It's a situation where we check for a GCF as always, and we would love for it to be able to be factored ABC method-wise, but we just don't have that, so we'll go into our slip and slide method. Before we do all of that, we've got to check the GCF. In this case here, we check for the GCF by starting off by the coefficients, and number 5, negative 17, and 6, divisible into that. No numbers divisible into that except for 1, and so we move on. Variables, x squared, x, and a constant, so we don't have a variable in each of those. So right here, again, we do not have a GCF. Then we take a look at that problem and we say that we would certainly enjoy doing the ABC method. It's been helpful in the past, but we would need an a value equal to 1, and we just don't have that right now. Our a value currently is the number 5. So because the a value is the number 5, we can't do the ABC method. But we can start the process of doing the slip and slide method in order to eventually get an a value equal to 1 and kind of move on. So here's my a value of 5. I'm going to go ahead and slip it into a c value 6 here. So what that would do then, if I use multiplication, would give me x squared. It's slipped out of the a value there. I got my b value, negative 17x, and then I multiply 5 times 6 to get 30. And now I have a situation where I have a quadratic equation, and that quadratic over here on the left side would have an a value of 1, so I'll get into my ABC method. 1, negative 17, and 30. The b value is a negative number here, so when I'm thinking about 30, I need either 2 positives or 2 negatives. So something like 1 and 30 wouldn't work, but negative 1 and negative 30 would eventually add up to be a negative number. Could have negative 2 and negative 15, negative 3 and negative 10, negative 5 and negative 6. I believe that might be it when it comes to the negatives. And I add them up and see what works. Negative 1 and negative 30 would add up to be negative 31. That doesn't work for us. Negative 2 plus negative 15 would in fact be negative 17. So this right here, this set of factors would multiply to negative 30, and it would add up to negative 17. So that's good. I'll go ahead and write that out in intercept form. X minus 2, x minus 15, and that's still equal to 0. Nothing's changed with that. But I gotta hold the phone here because we had previously slipped out a 5, and I'm going to go ahead and slide it back here underneath our factors of c that added to b. So I'm going to put divide by 5, and that's my action of sliding. Up here we slipped the 5 out, now we're sliding it back in. Take a look at those parentheses, take a look at those numbers in the parentheses. Do any of them reduce the whole numbers? And over here, hopefully we understand that 15 divided by 5, or negative 15 divided by 5 would be negative 3, so I can go ahead and clean that up. However, 2 over 5 would be a decimal if you type that into a calculator, so I'm going to take a moment here to, again, slide it just back up right there. 5x minus 2 is what I have. I got 5x minus 2, I got x minus 3. That now is in fact in intercept form. We're happy about that. So this right here is factored from the original problem. 5x minus 2, the quantity x minus 3 multiplied together. That is the factored form of that original up top here. Just use the zero product property now in order to solve the equation. 5x minus 2 is equal to 0. I'll go ahead now and just Solve that. I got 2/5. I believe if you type that into a calculator, it would be 0.4. And then I have a little bit easier of a one, x minus 3. And we figure out that our solution from that would be 3. So overall, the two answers to these the two solutions to this equation up here would be 2/5 and 3.